A practice question maybe. Okay. Have a look at this one. So we're going to do question 6 part I. So we've got 3 multiplied by 16 to the power of x minus 4 to the power of x plus 2 plus 5 equals 0. Now, before I go any further, technically, something like this could be asked in an exam, but it's highly unlikely, okay? The reason being is that because it's not any harder than what we've just looked at, it's just knowing your laws of indices and applying them. But the reason being is because when we write an exam, we have to make sure that the questions are balanced. In other words, we have enough proportion of questions which are accessible. In other words, anybody can pretty much get it. We have to have enough questions to kind of, which are kind of in the middle, to kind of make you think a little bit, but they're not too difficult. And we also have to have enough questions which kind of really push you and really kind of distinguish who is the really strong students compared to those who perhaps should be deserved of perhaps maybe 60 or 70%, okay? So this question, if it was going to appear on a paper, would be one of those questions that would really push you, okay, and really challenge you. Now that's not to say that you're not able to do this. Okay, so I never try and sort of put it from the perspective of saying, well, just because it's a really hard question, you shouldn't be bothering about it, because that's not the case at all. Anybody is able to do this, but it is designed to make you think. So if you're going through this and thinking, I would have never thought to do that, don't worry, okay? Hopefully you can sort of just pick up the methods and sort of understand things to help you practice other questions as well. Okay, so let's have a look at this. Now, what's different about this type of question compared to the questions that we've looked at before? Good, so the x plus 2, anything else? Look at the base. So before we had the 4 to the power of the unknown was the same in each of these two terms, wasn't it?
But like we could do it like 4 squared.
Perfect, well done, that's exactly what I wanted. So the two things that you notice is that this base and this base is different. Let's start off there. So let's write 16 as 4 to the power of 2. Excellent. So in other words, we get 3 times by 4 squared, all raised to the power of x, minus, okay, have a look at this, 4 to the power of x plus 2. You just want a 4 to the power of x. That's kind of where we assume that's going to go. Could you convert 4 to the power of x plus 2 into just a 4 to the power of x, perhaps with something else? Not quite. Think about your laws of indices, okay? You do know how to deal with this, it's just that you hardly ever deal with it in this way. Okay, let me show you what I mean. The answer is 4 to the power of x times by 4 to the power of 2, okay? Now the reason why I say you do know this, it's just you've never thought of it in this way, is because usually I give you this and I ask you to simplify to this. Does that make sense? So 4 to the power of x times by 4 to the power of 2, I say, what's that? Oh, okay, I just add the powers together. So I get 4 to the power of x plus 2. We hardly ever think about it the other way round. But you're happy it makes sense to, like it doesn't matter which way round you think about it. So what I want you to think of is that first law of indices, where you have something to a power times by the same base to a different power, you end up adding the powers. Instead of thinking it going from this way to this way all the time, so in other words you add the powers to get this, try and think about it the other way around as well. So in other words, if you have a power where you are adding, then you can just separate that out into the same base, but with the powers written individually, and then you're multiplying in the bases. Does that make sense? So it's a little bit of a kind of, the first time you see it, you go, oh yeah, of course it is, but you wouldn't necessarily notice it, okay? So just get used to the fact that yes, usually we go from this side to this side, but you can also go back the other way as well. So if you see adding in the powers, you can separate it out like that. So, in other words, you get minus this 4 to the power of x plus 2 business I can write as, well, instead of writing it as 4 squared, I'm going to write it as 16. You happy? So it's going to be 16 times by 4 to the power of x. And then obviously plus 5 equals 0. Okay, good. So now I'm just going to tidy this up slightly. Would you be happy this would become 3? You could write it 16, but then that's just where we've come from, isn't it?
No, why we put 16?
Why have we put 16 here? Ah, see that 4 squared? I'm just writing it as 16 instead.
Oh.
Does that make sense? Yeah, so 4 squared times 4 to the power of x, that's 16 times 4 to the power of x, yeah. Okay, so I've got 3. Now this, I want to write it as 4 to the power of x. I'm going to write it as 4 to the power of x, all raised to the power of 2. So in fact, I can get rid of that and put a multiply down there instead. And likewise, I've still got minus 16 times by 4 to the power of x plus 5 equals 0. Now, are you happy that this is looking a bit more like the questions that I've given you in just a minute ago? Yeah? So in other words, I'm going to let u equal 4 to the power of x, which means that I get 3 times by u squared minus 16 times u plus 5 equals 0. Can you have a go at factorising that for me? So what did you factorise this to? Just give me the 2 brackets.
U minus 5, 3u minus
3u minus 1. Good. Which means u equals 5, or u equals a third. So, obviously u is equal to 4 to the power of x. So we get 4 to the power of x equals 5, or 4 to the power of x equals 1/3. Which means that x in each case will be log to the base 4 of 5, or x equals log to the base 4 of 1/3. Okay, so for this one, for log to the base 4 of 5, what should you get?
1.16.
1.16. And for the second logarithm?
Negative 0.79.
Negative 0.79. Excellent, well done. Okay, so are you happy? Yes, it is different, because I give you this. You have to keep your wits about you with this one. Okay, fine, you got that one. That one there may take a little bit more recognition, a little bit more practice, but to be honest with you, once you're here, it's relatively straightforward to get to here. It's just being confident with your laws of logs, and then there, sorry, not laws of logs, laws of indices, and then from there, it's straightforward again. Now, the reason why I say that this would be a more kind of, this would be a question which would challenge people and which we put in to challenge people. Are you happy the actual mathematics itself that you're using is relatively straightforward? It's all mathematics we're using before. So indices, yeah, use those before, use those laws, and again, using that law as well, okay? The challenge is, can you be confident enough to recognize it, okay? Because I would question how many people would look at this, to look at this 4 to the power of x plus 2 and realize that that was just 4 to the power of x times by 4 to the power of 2, yeah? If you just kind of sat there and maybe 5 minutes before the exam just revise the laws of indices and think, okay, I'll see if I can get by, you probably wouldn't get that. You need to be really confident with using these kind of things, and that's kind of what we want to test. Yeah, it's not so much a case of the mathematics as such, because the mathematics is actually straightforward-ish. The thing which we're trying to test is, can you be confident enough to try and manipulate this stuff? Yeah. Good. Are there any questions about that?